Alright, so first thing we need to do is get the aggregate of the max damper positions, of the damper positions. In this case, our aggregate is going to be a max, but it could be the average. This would be a pretty neat one to, pretty neat spot to use the program we made for the for loops. Where you get a quorum, and then you can identify zones that are outside of a certain tolerance range using the standard deviation, and you can identify rogue zones like that and then take them out of the calculation, or programmatically start to change your trim or start to change your set point and so on. So there's a lot more complexity that could still be added to these functions and control loops. So max damper is going to be maximum. Next thing we're going to do is very nice and easy. Assign, instantiate the function trim and respond, and then assign its returned value to the set point. So, and then here we're gonna have to say our max damper is the sensor or the input value, the process variable. Zone damper position set point is our set point. Our pressure set point is our control variable, the one we're trying to change. Our deadbands for were enabled. Our trim, so we can see it react fast, it's going to be 0.05, but truthfully, and you'll see why when we debug, you want this value small, because you don't want these changes to occur fast. I would always set this value to no more than 0.02, but typically as low as 0.0005. So you'll have to play and find the sweet spot, I guess, on your own. So, and then our hard limits are going to be 1.7 on the high end and 0.65 on the low end. So we get an error. 21. Oh, wrong name. Okay, saving successful. So we'll have to bind a few more thingies here. Looks like we got all the names right. Save. Okay, so since our set point is 85 and zone damper number 1 is half degree above the set point plus the deadband divided by 2, so 2 degrees because our deadband's 4, we're increasing our set point because so if our VAV zone damper 1 and every other one will continue to open, if these dampers keep opening, it means they need more flow. So hence we're increasing our supply set point. These dampers keep on going up. We keep on adding to the set point. think this is actually a very nice control loop if you can implement it right. It's difficult to implement though, but it certainly keeps your fan from ramping up really fast. So now if we bring this down again, say to 55, then right away we start decreasing or trimming our supply fan pressure set point, because we are feeding the VAVs more than the design minimum, or whatever their airflow set point is at the moment based on their load. So they're closing down more than what we want them to, and they're causing backup pressure that the fan has to work against in order to maintain whatever the set point was. So this is what reset and trim and respond looks like, and this is how I would do my control loops in the programs that use them.